Hello, my name is Frederick Janson, and this is the second part to the Change, Value, Behavior, and Performance series. This section addresses the introduction to the nature of change. Heraclitus the Greek is among the first to be credited with observing the constant nature of change. However, there is subjective reality, the way we think things are, and objective reality, the way things actually are. Just because we think something is real, subjective reality, doesn't mean it is real, objective reality. The resulting truisms: everything is real and nothing is not real. To align all worldviews, there are many different words in many different languages used to describe or value everything, including but not limited to infinite change, infinite power, infinite energy over infinite time, infinite space, gods, God, supreme being, and or grand architect of the universe, potentially all different ways of saying the same thing. Each language has its own words, sounds, and context to describe internal and external change. Much like ice, snow, frost, mist, dew, rain, vapor, steam, clouds, and H2O are all English language words and sounds that describe the same thing, water, isn't it possible that the languages of the world are employing many different words, sounds, and contexts to describe the same thing, everything? Infinite change, infinite power, infinite energy over infinite time, infinite space, God, gods, supreme being, and or great architect of the universe, from which we all come from, are a part of, and to which we all return. The answer to this question is more likely yes than no. Using worldviews to establish that there are many different ways to say the same thing, by focusing on the similarities and not the differences, consider the following about the nature of infinite power. Sir Isaac Newton was the first to measure that some part of everything, energy, could not be created or destroyed, only transferred or changed. Returning to Heraclitus, who observed the constant nature of change, he was observing Newton's constantly changing energy given the following. Albert Einstein was the first to measure that energy and mass are proportional, such that anything with mass has an equivalent amount of energy. Accordingly, we in the environment are Einstein and Newton's constantly changing energy because we have mass, and therefore we have a proportionate amount of energy that cannot be created or destroyed, only changed. In summary, we have been, and we will be a part of infinitely changing everything: power, energy over time, space, God, gods, supreme being, supreme beings, and or the grand architect of the universe. We change everything, and everything changes us, as illustrated by the butterfly effect in James Gleick's Chaos, Making a New Science, which describes how multivariate systems instantaneously and perpetually change themselves, changing change, or everything changing everything. In his book, he describes how the fluttering of a butterfly on one side of the planet can cause a major climate-based natural disaster on the other side of the planet. Using a variation of this example, a bee bites a zebra, who suddenly takes off running, scaring all of the other grazing animals, resulting in a cascade effect whereby all of the grazing animals take off running, which creates a micro-wind and which stirs dust into the air, both of which alter the microclimate above the animals, causing cloud seeding, which then affects the local climate, which then affects the regional climate, which then affects the global air circulation, which then gives a hurricane just enough energy to reach the shore, which then has just enough energy to displace a levee, which results in massive flooding, which results in massive destruction and untold deaths. It's hard to imagine that something so small like a butterfly or a bee could have such a large impact on such a large system, and there are many more smaller things which change everything significantly on a moment-to-moment basis. A nuclear detonation is another example of how something small and seemingly insignificant, like an atom, can have a major impact. Consider that purified heavy atoms like uranium atoms, with a quantity of no more than the size of 2 grapefruits, when smashed together can destroy pretty much everything in their path within a 5 to 10 mile radius and contaminate soil, water, and or air for a lifetime. A third example of how a small change can affect large-scale change examines microscopic pathogens like the smallest prions, protein particles that cause mad cow disease, or the slightly larger viruses, mostly protein and genetic molecules that cause influenza, AIDS, smallpox, and Ebola, or even the larger bacterial and fungal cells which cause sepsis and flesh-eating disease, or even the larger cancer cell. How many lives, How much productivity and how much money have these small things claimed? Of course, if small things can cause big changes, then bigger things can cause even bigger changes, as they have more energy or power to influence change. But larger things don't always cause bigger changes. Therefore, every small thing changes every big thing to some extent, and every big thing changes every small thing to some extent. Returning to Glegg's chaos theory above, each variable in his multivariate system was observed to instantly change the value of each other variable, which then instantly changed the value of each other variable, resulting in a chaotic set of measurements with some degree of order or structure to the chaos. When plotted, yielded infinite fractal images. Google fractals to see what a fractal looks like, and it turns out these infinite relationships are ubiquitous or omnipresent in nature. Benoit and Mandelbrot first created number sets and equations to describe these types of chaotic systems, to predict when structure would occur in chaos, and the results were amazing. His number sets and equations can be used to predict how a mountain, seashell, snowflake, or broccoli will change shape, how financial markets behave, where a branch will occur on a tree, where a tree will be found in a forest, when a storm will occur, how a virus will change with time, and how antibodies will change to respond to a changing virus, obviously with some degree of error.